Alright everybody, here we are, and I hope you guys are doing great. This live is again going to be at least 2 hours long, and in this particular live I will mainly be focusing on WebRTC section, and let's see how many things we can actually cover today. So let's do one thing, just right here set a timer for 2 hours. Many things are here, let's simply get rid of them. I'm gonna be setting a timer for 2 hours, and in this particular section I will mainly be learning about WebRTC. Okay, talking about the things that I've actually learned so far. First of all, let me make sure I'm audible and all. Yeah, I'm audible. And talking about the topics that I'm gonna be learning right now, they're gonna be pretty simple, mainly in the WebRTC section. Let's remove the extra things that I have here. WhatsApp clone scheme and all, not really. Control Shift T. I need ChatGPT. Apart from this particular thing, this is not quite working nowadays, so I'm gonna be just simply removing this particular part from here. Someday it worked, but not now. Or maybe I was working with the yarn over there. Don't know about yarn. Let's keep it here. Maybe someday it's gonna be useful or not. Okay, apart from this particular thing, I'm mainly gonna be focusing on the WebRTC section. That simply means that I can go here, software, Udemy, and WebRTC. So far talking about the things, exactly how many things I've covered. So first of all, okay, this ad camera is pretty much simple, easy peasy. Then I learned about NAT. Again, NAT is something that's your routers use NAT, and they just simply make a connection between your private address and public address, just as simple as that. Especially whenever you just create a connection at that time, first of all you create a peer connection. Once the peer connection is ready, after that you just add the information about the data channel you wish to send and receive to your peer connection. So ultimately you add more things, and once that is added, then you create the offer. Once the offer is created, you set the local description, then WS signal server, ICE candidates turn, and WS candidate server, and all these things are here. And it's simply time to just simply go through all the things mentioned here, because if I don't go through them, then again things are gonna be a bit problematic, and that is why right now I'm just simply gonna be going through all the content that I have written over here. So first of all, every device on the web has to have an identity IP address. NAT allows IP addresses sharing. Many devices on LAN local area network can share one WAN wide network area, and mainly NAT plays the role here. NAT is primarily implemented by routers. Routers primarily implement NAT. Your router will create a table that maps all the active connections between internal private IP addresses and their corresponding external public IP addresses. When it comes to NAT, so there are three types of NATs: static NAT, dynamic NAT, and PAT address translation. No need to go deeper into them. If it's needed, I will be going through them. The problem statement is that individual computers may not have unique IP addresses. That is right. Devices IP address can change when moving between networks or due to NAT changes. That is right, and that is where we use something called ICE framework. Let's even go through that. But every unique network connection which includes a WebRTC is identified by 5 tuple, which consists of 5 specific parameters that collectively provide a distinct identifier for that connection. The components are source IP address. This is the IP address of the device. The device initializing the WebRTC connection. For example, this info may contain both your public IP address and private IP addresses. So source IP addresses. After that, destination IP addresses. This is the IP address of the WebRTC device you intend to connect with. This may contain both their IP addresses and public IP addresses as well as private IP addresses. Then there is something called source port. This is a port number that your browser has allocated to your PC for the WebRTC connection, which is typically a dynamically assigned ephemeral port. Okay. Destination port number. Similarly, this is the port number on the destination device that you are waiting to establish a connection with. For HTTP, this will be port 80 or 443, but for WebRTC, this will be the other browsers, other users' private port number. So whichever port is being used. Alrighty, then transport protocol. This indicates the protocol used for communication. WebRTC uses either TCP transmission control protocol or UDP, user datagram protocol. This is how overall things are. I'm not gonna be describing them much. I just simply wanted to go through them and have a look at them once. Each ICE candidate is assigned a priority value, which is a number ranging from 1 to 2000. This particular range. A higher value indicates a more desirable candidate for establishing a connection. The browser's ICE agent is responsible for setting these priority values according to ICE specification outlined by IETF. What is actually happening over here? There is something called ICE framework. Okay, so when you are actually working with a WebRTC, so at that time ICE framework mainly handles everything. So ultimately, first of all, routers with the help of net, they just simply map your private addresses to the public addresses. On top of that, ICE framework is used. ICE framework is inbuilt in your browser only, so whether you are on Chrome or Brave or any browser, does not matter which that is. ICE frameworks are inbuilt, they are already there. You can just simply ICE, you will be getting ICE agents in ICE framework, and those agents will be getting the things done. So ultimately, ICE frame will create the candidates. That can be candidate 1, candidate in the sense best way or best route to just get connected to the another device. So that can be the host candidate, or that can be the stun candidate. I mean, or there's another thing called return. So that can be any one of them. And what exactly happens in the candidate? First of all, if there is a candidate and that is getting connected via TCP protocol, and IP address is this, port number is this, and then this is how you will be able to connect to the other device. Or it could be that that is using UDP connection. So either you can use TCP connection, or you can use UDP connection, or you cannot use Eastern connection. Rather, you will be using the host connection, because maybe the device you are trying to connect, that is just nearby in the same network. At that time, UDP or TCP, any one of them can be used, and this is how you will be getting connected. Kind of, yeah, it is definitely hard to understand, especially if you are going through it for the first time. But you need to know overall everything, then only these things are gonna make sense. But if you have knowledge of WebRTC and also, you should be getting the idea exactly what I'm talking about. By the way, let's continue from here on. By the way, which candidate is gonna be selected? There can be many candidates, right? There can be a candidate using TCP protocol, there can be a candidate using UDP protocol, there can be a candidate using a UDP plus host, host candidate, or there can be stun candidate. So they are mainly selected on the basis of the priority, and priority is set by what? Priority is set by ICE candidate. Okay, establishing connection, the browser's ICE agent, they just simply provide the priority to those ICE candidates. This particular thing is done. This is the overall what steps that actually are followed for getting WebRTC connection ready or connected. So ultimately, first of all, you need to create a PC connection, peer connection. Once that connection is ready, after that you need to just add some information over there. Some information in the sense kind of adding the IP addresses, private IP address, public IP, mainly private IP address, public IP address, your port number, your transport protocol, and also you will be adding everything here. And after that, you will be creating an offer. And once the offer is created, you will be setting everything in the local description. Once everything is set, you will be just simply signaling that signaling that okay, now everything is ready, you can get connected. But again, there's a lot. This is not just gonna be here done, so we of course have to go through a lot. Then there is something called ICE framework. As I told you, this is already built in your browser itself. The process to find a device on the internet, at that time ICE framework is going to be used. When you create RTCP peer connection object, set up your WebRTC application, your browser will automatically gather information about your PC's identity, so that the another peer can find you. First of all, using this let PC new RTC peer connection, using this particular object, you can actually create a new peer connection. And once that is created, the ICE framework, it will automatically get the information about your PC, and once it gets the information about your PC, it will trigger ultimately it will let your browser know that it's ready for that. Ultimately it's ready. Ultimately WebRTC connection is ready, and it's ready to be connected and all. There can be 2 to 3 things over here: public from outers, public IP, private port, transport protocol, and all. In reality, most devices live behind net. That is also right, because ultimately routers handle all these things, and behind the scene routers use net. WebRTC applications use the ICE framework to overcome the complexities of real world networking. Ultimately, if you are not using ICE frameworks, you will have to do most of the things manually. So ultimately, ICE frameworks handle these things on behalf of you. ICE tries to find the best path candidate to connect peers. First of all, there can be many candidates. Like there can be a candidate, there can be stun candidates, there can be host candidates, then there can be a candidate using UDP protocol, user datagram protocol. There can be a candidate using TCP transport layer, TCP transport TCP full form. Am I not gonna get that today? TCP Transport protocol. Come on, yaar, what is the full form of that? That's crazy. Da. It's actually da. TCP full form. Am I kidding? I don't have that. No, I must have TCP, transport layer protocol. Let's search here directly. TCP. Okay, so what is the full form of this TCP? Interesting. Let's search one thing. Control F. Transport. Yeah, not transport. I have only one of them. Literally. That must be somewhere here. Alrighty, so this is the transmission control protocol. So there are two things: user datagram protocol or a transmission control protocol. Let me just have, get them written here. So ultimately, if I just actually have a look at that. So the first one is going to be TCP, and that's gonna be transmission control protocol, just like this. And there is something called UDP, user datagram protocol. Alrighty, by the way, let's continue from here on. So once this thing is done, so transport, where was I? Okay, I was here. So overcome complexities of real world networking. ICE tries to find the best path, ultimately it finds the best candidate. Every browser has the code ICE agent that allows to try and find the best possible routes. That means ICE candidate to your PC, that is right, to your PC, ultimately peer connection. It should be for your PC. The ICE agent operates within the browser's WebRTC implementation, that is also right. It is integrated into the RTCP peer connection object, so it is actually integrated inside that. And that simply means that the ICE framework is integrated in your browser's WebRTC connection itself, and especially when it comes to RTCP peer connection, and you can use ICE agents, and those agents are gonna be getting the things done. The process of find a device on the internet, the collection of ICE candidates, there can be many candidates, that is right, is referred as the gathering phase. So ultimately, first of all, as soon as you just create this peer connection, so lots of candidates start getting gathered. Ultimately you will get lots of candidates, and then the best candidate is going to be selected based on the situation. And this is triggered by the addition of a new media section to the local session description. So as soon as in the local session description you add media, so ultimately the ICE agents, they start finding the candidates. So ultimately, this is the job of ICE agents, right? They will find the candidates and all. After that, when a new gathering phase starts, ICE agent will notify RTCP peer connection object that a gathering is occurring through a state change event. That's simple. Once you have added the media, that means the media got added. Once the media got added, then agents will tell to this RTCP peer connection, ultimately peer connection, that okay, gathering has started and the event is changing and all, just like this. When a new ICE candidate becomes available, the agent will supply it to the RTCP peer connection object via on ICE candidate event. So ultimately, whenever the candidate is ready, ICE agents will simply give the connection to RTCP peer connection, so that it can actually make a bond or connection. These candidates will automatically be added to local session description. Not quite automatically, you will have to set them, but yeah, they're kind of added by the ICE agent. So they will be set by the ICE agent, so you will have to set them. When all candidates have been gathered, a final on ICE candidate event will be emitted. Like once candidate is confirmed, like this particular candidate in the sense this particular route will be used using TCP or UDP protocol and all, that okay, using this particular route or candidate, I'm gonna be getting a connection ready between me and the client. After that, a last event is also emitted as well, and with the value null to signal that gathering process is complete. So ultimately, once gathering process starts, ICE agents tell to RTCP connection that okay, RTCP peer connection, that gathering has started. After that, once even the candidate is selected, like this is the candidate that's gonna be used, they even tell this thing, they send that particular candidate to the RTCP peer connection. After that, at the end they even send like emit an event, and they tell like okay with the null value, and this null value simply specifies that gathering is done, candidate is selected, now it's time to get connected. Okay, just like that. Okay, by the way, I have to just simply continue from here on, never mind. Apart from this particular thing, there is something called ICE gathering state. ICE gathering state in the sense ICE agents, they actually started gathering the state of the RTCP peer connection. Okay, so this is the first thing. It can be new, it can be gathering, it can be complete. Like as soon as you get connected, so ICE gathering state is new. Again, ICE frameworks are gonna be used for kind of for the connection and all, even for finding the candidates and all. So first of all, that's gonna be equals to new. After that, that's gonna be equals to gathering, like okay, it is gathering the information about your PC, and then it is even selecting the candidate and all. And after that, once everything's done, it will be just simply complete event listener ICE gathering state change. So even I will be listening on ICE gathering state change event. Once all these things get done, after that ICE connection state can be new, connected, or completed. That is also right. So there is something, three things are actually here. First of all, ICE gathering state, that can be either new, then can be connected, or ICE connection state. So ICE gathering state, when it comes to gathering state, so when you are actually gathering the information about your PC, that can be new, like you have just joined. Now that can be gathering, you are gathering the information, or that can be you are complete, right? You have gathered the information. Okay, and when it comes to ICE connection state, like I'm mainly talking about the connection over here. So the connection can be new, the connection can be connected. Right now it is connected, and the connection can actually be completed. Completed in the sense connection is completely established, everything's done. Now you can just simply go ahead with the things. By the way, I will be even writing the manual code too, so that it gets easier to understand. But for now, let's simply go ahead. A connected state indicates unusual connection has been established. A usable connection has been established, but ICE agents may still be checking for better candidates. The completed state goes on one step further by signifying that all candidates pairs have been checked and connection is confirmed for all the components and all. That's fine. Lastly, I have a link for WebRTC internals. If you actually want to check the kind of status of the WebRTC connection, you can go to this Chrome and this WebRTC internals, and you will be able to see that. On Edge, not even Edge, on Firefox, you can go to this particular thing. This is mainly for Firefox, not Box, just Fox, and the upper one is for Chrome. And this is how you will be getting the things and all. By the way, over here you are getting three things: RID, LID, PID. PID of course stands for process ID. And let's go through some more ones. So RID, the render ID, helps track which browser is associated with the peer connection. So you have a peer connection PC, and it will mainly be used for rendering things like which particular browser is associated with this. LID, the local ID assigned to peer connection instance, and helps uniquely identify it within the rendering process. So the local ID assigned to peer connection instance and helps uniquely identify it. The local ID is assigned to the peer connection instance and helps uniquely identify it within the rendering process. So first of all, there's gonna be a browser connected associated with RTCP connection and peer connection, and once that is mainly RID, render ID is going to be used over there. Render ID in the sense it will just make sure that which browser is actually associated. LID LID is assigned to the peer connection instance and helps uniquely identify within the rendering process. So the connection that we have, that is uniquely kind of identified, and because of that thing we use LID. And lastly we have PID. Each type in browser runs in a separate process and known as PID, allows for efficient handling of these processes and all. Okay, overall knowledge we have right now. Then there is something called session description. About info about WebRTC connections, you need to create a set of instruction session descriptions that tells to devices like computers or smartphones how to communicate with each other. Local description, when it comes to the local description set, using set local description after you create an offer. Again, one more thing, from your side you will be creating offer, from the client side you will be getting answer. So it's gonna be just like that, so keep that particular thing in mind as well. And there is something called remote, nothing's here, that's fine. Let's make it better. And these are the things that you actually get inside the offer. You get a version, you get a origin, you get a session, you get time, you get these attributes as well. Okay, every WebRTC connection is managed by session description. So each peer will have what? Their own local session description, pc.local description. The other PC is session description, PC remote description. So ultimately there are two things: local description, remote description. Local description will contain the information of your PC. Remote description will contain the information of the remote device, so that you are actually able to connect and all. The information contained inside of this description object is governed by rules set by JSEP. Again, this is kind of an organization. Can't even call it an okay, let's name it an organization. This is something that actually kind of an organization that actually decides what kind of what can I say, rules are gonna be used, and information contained inside of these descriptions, ultimately a local description and remote description, the rules are defined by this JSEP and all. And when it comes to JSEP, JSEP is like a traffic controller. HDB is the language that JSEP uses to describe the WebRTC connection session. The thing is that JSEP uses HDP not because it is the most efficient format, rather it is widely accepted. Lots of people use it, and because of that thing, everyone is using it, so everyone is using it. Okay, by the way, when it comes to the session description, so JSEP's session description uses session description protocol, SDP session description protocol syntax for their internal representation. While this format is not optimal for manipulation from JavaScript, it is widely accepted. That's what I was talking about, and is frequently used with the new features. Any alternate encoding of a session description would have what is there, and come on, would have to keep pace with the changes to SDP, at least until the time that is the new encoding until the time that this new encoding leaves the SDP in popularity. Rules about the format of session data. An SDP message is structured as a series of lines. Okay, an SDP message is structured as a series of lines, each representing a specific type of information related to a multimedia session key value structure. That's right. JSEP does not force us to use any particular signaling model or state machine, but it does force us to record and exchange session descriptions in the fashion described by this offer and answer. JSEP provides a mechanism to create offers and answers as well as to apply them to a session. JSEP also manages the format of ICE candidates and adds them to the local descriptions accordingly. The thing is that I've been going through the only theory so far, and understanding just theory without any practical stuff really gets hard. So let's do the practical thing right now. Practical thing in the sense we are even gonna be creating the offer and all, and when we actually get the things done practically, then we are gonna be understanding even better. For doing that thing, I have session starting files, WebRTC. I am gonna be going here. Let's go to other locations, projects over here, and after that where should I go? Udemy. WebRTC, where am I gonna be getting it from? Starting files, fast API, come on, okay, better auth is here, true feedback is here. Session is related to the passport if I'm not wrong, and that is absolutely right. So just a sec. Alrighty. It turns out that I must have inside downloads or something. Session cookie, code. I don't even have that here. I have songs. Where do I have this WebRTC thing? Yeah. This I sometimes actually forget like where I've actually written the code and all. What's the fast API starting files? Let's even check this thing out. Okay, this is the starting files. I had better name it WebRTC. I thought these were the starting files of something else. Never mind, let's simply open this particular thing here. I will be even going through the code, like exactly how the things are actually happening over here. First of all, I have this index.html, and there's nothing. There is simply a video tag, and inside this I'm simply adding the like streaming my video and all. That's it. So let's get rid of this particular page. Main things are actually happening over here, and not only this thing. This is the kind of async await, not async await, then in catch block way, but I'm not gonna be using that. Rather, I'm gonna be going with the async await manner, because that does not take lots of space and all. It's just, that's easy to just understand. By the way, this is the peer connection object and a variable, and by default that's equals to null. And mainly the things start from here. So first of all, I'm getting the local stream. Await navigator media devices get users. First of all, I'm getting the user, and after that, this is the device ID that I'm actually using. How did I get this? It's as simple as that. You can just search it in your Chrome. Again, for getting this particular device ID, you have to just implement this particular method. So if you just run this code, you will get all the devices that are actually on your you will get all the media sources, and then you can get the ID of them, and you can just simply paste the ID. By the way, I will not be using it over here. So I got the ID that is already set. Once after I got that, I'm just simply adding a local string to the source object. Once that is done, I will be able to see that. After that, I'm creating a new RTC peer connection. Once the connection is ready, then I'm gonna be creating an offer. Again, just after this, you have to add some more things over here. Some more things in the sense you need to add more things to the offer, but that's not done yet, so I'll be getting that done. But I'm creating offer over here. For creating the offer, pc.create offer, this is how the offer is going to be created. By the way, I'm mainly implementing WebRTC over here. So far till here, I've been just simply streaming my own video to the screen only. That does not really make a lot of difference. And from here on, WebRTC is going to be implemented. So first of all, I'm creating my peer connection. Once that is ready, I'm actually creating the offer. Once the offer is created, then offer does, I mean, it has some values by default, so I don't really need to do anything. And at the end of that, say I'm gonna be adding the offer to the PC object. You will have to set the offer to the set a local description, because by default it's not gonna be set, so you'll have to just keep this particular thing in mind. And that is it. Once all these things are done, then you don't really need to worry about this. I'm initializing the WebRTC over here. Okay, pretty much simple. Let's do one thing. Let's simply go live using this. This is bad. I can go to index.html and I can go live using this. So I'm gonna be here, and once I'm actually here, then I should be able to just simply connect. But if I'm not able to connect, then I'll have to take care of that. But let's see how it's gonna be going on. Especially if I want to get connected, that simply means that, first of all, let's keep it aside. Okay, WebRTC, reload the page. Why am I not getting anything here? Sorry for that. Overstream student container. If I'm not getting any result here, what could be the reason? This usually does not happen. As soon as I click on this, hang on for a sec, this initialize WebRTC is called, and as soon as that is called, just a sec. Something that, let's do one thing first of all. Let's use this particular method that I've actually created. I will be getting all the IDs, and after that, once I have the IDs, I will be working with something else, like error stream over constant error main.js 58 number line console error getting the stream. Okay, and that's error. That means I'm actually facing an error right now. Why am I getting the error? The simple reason can be like this particular ID that I'm using, that ID is not right, and that ID is not right. That could be problematic. Yeah, So especially if I want to make sure that the ID is right, then I'll have to get all the current IDs that are there. So I'll have to make it video true, because without this I will not be even getting anything. So if I reload the page, just a sec, if I simply reload the page, come on, yeah, if I simply reload the page, I'm gonna be getting the devices, but there's no ID and all. For that particular thing, I'll have to make add the media source over here. So media is gonna be video, and that's gonna be true. So I will be using the media and all. Once this particular thing is done, then I'm getting this option to use the camera. Once I just click on allow and I click on this, just I reload the page. Now I'm getting all the medias, but I'm getting only one media. For getting another media, I'll have to turn it on. I'll even have to get my mobile connected. Let's do that. Just a sec. I doing webcam. Come on, where is that app? Okay, here it is. It's gonna be connected right now. Oh yeah, it is. I can keep it like this. Interesting. So this is actually gonna be like this. I hope I'm visible too. Never mind. So this is how it's gonna be going on. Ultimately it is connected, and right now I have this particular media source as well. If I reload the page, I will be getting the ID of this. I think the ID is wrong that I'm actually using right now. Control C, and let's simply go here and let's simply change the ID. Not really, the ID is not wrong actually. So let's do one thing. If the ID is not wrong, maybe the media was not there ultimately. This, but it's okay, this could be the reason. This particular device ID was not present, and because of that thing I was getting the error. It could be the reason. I haven't really changed anything. Everything else is still the same. I'll simply be commenting it right now, and let's see whether I actually get it or not. And it is working actually. So reload the page. Let's click on reset permission. Right now I can reload the page. I'm getting allow while visiting this site. Yeah, definitely do that. And now I'm actually visible over here. And kind of that's what I wanted. So far I've gone through this much, but this is not the only one thing. If you actually have a look at this, so what I'm doing, first of all, again, even if I just comment this much section, nothing is gonna be happening, because this has no role to play for just displaying this. So this is just simply getting my video and displaying over here. That's simply easy peasy thing. But the next thing is that I can actually create my RTCP connection, and once that connection is ready, then I can get the things done. So first of all, RTCP connection is ready. After that, I'm creating an offer. Offer will contain mainly the information about my connection, as simple as that. By the way, I'm not actually adding anything in the offer right now. I'm just simply saying that offer got created, and then I'm setting the offer in the local description. That's it. So let's check this thing out. So if I click on F12 right here, reload the page, and so offer got created. This is the offer that I'm actually getting. If you just hover over the offer, so you are getting this thing just right here, like you are getting the version, origin, session, time, and all these things are visible over here. So these are the fields inside the offer. The another thing is that this is getting logged over here. Why is this getting logged? This is getting logged because I'm logging the offer here. That's fine. And the next thing is that it is actually set to the local description. So if I go to local description, if I just write PC over here, I got my peer connection. And if I check my local description over here, so this is the same thing that I'm getting inside my local description as well. So first of all, I created the offer. After that, I just set that offer to the local description, just like this, again using a method. Now what is gonna be happening after this? To be honest, I have no idea, because I'm yet to just go through the course. So right now I'm just simply gonna be muting myself, so that of course I don't have to speak, and I'm gonna be just watching the video, learning the things, and at the end of the day I will be explaining exactly how many things I learned and all. Again, the overall goal is going to be not goal, rather I will be giving it 2 hours again. If I don't give it at least 2 hours, it doesn't feel like I have learned something. So I will be giving it 2 hours. So far I have been explaining, so I took around half an hour. That's crazy, but never mind. Let's get it done right now. So I'm gonna be catching up soon once all these things are done. I'm gonna be just simply focusing on study right now.
I'm walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul. We are heroes tonight. We will fly above the sky. We are heroes tonight. Yeah. We are heroes tonight. We will fly above the sky. We are heroes tonight. Feel like a dynamite, ready to explode right up in the sky. I need you to listen, I need you to hear, and don't show any fear. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul. We are heroes tonight. We will fly above the sky. We are heroes tonight. Yeah. We are heroes tonight. We will fly above the sky. We are heroes tonight. I've been flying from town to town, from London to Taiwan. I've been all around the globe, trying to protect your soul.
That's good.
Yeah.
I get up, time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. See the horizon, turn us to thousands, and we'll grow in number, fueled by them. To see the horizon, turn us to thousands, and on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on
Alright everybody, here we are after 1.5 hour. By the way, as for the timer, 58 minutes are still remaining. Oh my god. Sometimes I do crazy things. I just revise the things for half an hour. After that I set the timer for 2 hours. That means I had to just simply study it for 2 hours. And insane, I studied for 1 hour. 1 hour is still remaining. That means I'll have to come back and then continue from here on. But never mind, this much we have covered so far, especially talking about the things. So first of all, we got the local stream. Once we got the local stream, we even added to the source object. After that, we started implementing the WebRTC from here. We got the new connection ready. We got the new instance of RTCP peer connection. Once that is there, even we got all the tracks. This is optional, but you will be able to see the tracks. Again, this is not optional. You'll actually have to add the track to the offer. The thing is that peer connection dot track, so you will have to add the tracks to that particular peer connection. If you do not, then offer will not have that, those values and all. then you are actually creating the offer. Offer will contain everything related to that. Once that's done, then you are just simply getting the stats of exactly you are simply getting the report and all, how many things are there. You are getting the report of the connections. So track added to RPC, and after that you are just simply adding it to the local description. Once that is done, then you are even listening to event that is on ICE candidate, and you will be getting event, and this event will tell you about the candidates that are available. So listen for ICE candidates together, and that's it, nothing else. You are not really doing anything else apart from this particular thing. One more thing is that there is something called RECV only, kind of. This is the send. There is something called ki, you have a media, right, and you want to send the same type of media, you want to receive the same type of media, so you will be using in that case send RCV, and but this time RECV only. That means you will be only receiving that particular media. It's gonna be just like that. If you actually click on this, and if you have a look over here, so A is gonna be send RECV if that's equals to that. So I will be just simply replacing that with the receive only and all. So this is the only thing. This is also one of the things that I got done over here, and this is how it got done. It's time to just take a break for 10 minutes around. I'm gonna be just taking a break, taking a like stroll around, and then after that I'm gonna be coming back. Until then, take care. I'm gonna be catching up soon. See you.